Hello again. So our starter today is to choose the most suitable word to fit the following descriptions. So we've got a list of words: antibiotic, antigen, antibody, and then we've got a list at the bottom of definitions. There are 11 words and only 10 definitions. So once you've done some matching, I want you to find the word without a definition and write a definition for it. So pause the video here and give it a go in your books. As the answers appear on the screen, just check that you've matched up the right ones. As a bit of a recap from last lesson, I want you to give this 3-marker a go. 3 marks, 3 minutes, pause the video, have a try. So because this question was only a 3-marker, you didn't actually have to go into that much detail about the immune response, but here are some of the points that you could have had. So point 1 is that there has to be exposure to the pathogen. You could have also said bacteria here, or antigen, or toxin. So it tells you in the question that scarlet fever is caused by Streptococcus bacteria. And point 2 was simply just to state that this exposure of the pathogen stimulates an immune response. You didn't have to really say any more than that. You didn't have to specify primary immune response, for example. And then the next point that you could have is that the immune response really is the production of lymphocytes, or you could have said the production of antibodies, because lymphocytes are the cells that produce antibodies, so it's sort of the same thing. You could also have said antitoxins here. So if you'd have said that there was exposure to the toxin, you could say there's production of an antitoxin, but this isn't always on the mark scheme, so I might steer clear of that. And then the final thing is the all-important production of memory lymphocytes. Okay, now we're kind of ready to move on to what today's lesson is all about, which is vaccinations. And first of all, I want you to watch a video other than this video. So some questions are going to appear on the screen now, and they're questions I want you to answer while you're watching this other video. So maybe once the questions are all on screen, pause the video, take a picture or write them down in your book, and then have a look for the link to the other video, which will be posted on our post or our assignment on Teams. Welcome back. I hope you enjoyed that video. I know parts of it are really gross, so I'm sorry for that. But the answers to the questions are just going to appear on the screen, so just check if you've got the right sorts of answers. So for question 2, why did smallpox kill so many people? It's because it's an infectious disease that spreads really easily between people who get close. So just a reminder of a key word from a couple of weeks ago is that means smallpox is a communicable disease. Remember, we say communicable and not contagious. And the real point of view watching that video was so you could see how the idea of vaccinating people against diseases first came about. I think it's a really interesting and kind of gross story. Alright, now that we have seen how the idea of vaccinations first came about, I'm going to tell you how vaccinations actually work. And this story is actually going to be pretty much entirely familiar from the previous lesson. It's really, really similar. But I think it's important to understand, and it's so relevant at the moment while obviously with the COVID vaccines and lots of adults having had the COVID vaccine now, and you guys wondering whether you'll be able to get it and when you might be able to get it if you can. So here we go. Just note up the top of the screen there it says vaccination/immunisation, but then it's got jab crossed out in a red circle. So make sure in an exam you don't use the term jab. I know it's quite often used in normal language, but it can't be in a biology exam. So the first step of a vaccination is to inject a dead or an inactive form of the pathogen into a person's bloodstream. So we don't inject the whole virus or a live version of the virus because that would make you ill. It would be able to replicate inside your body, and it would make you feel unwell as you were trying to fight it off. So instead, we kind of inject, you think of it like fragments almost, if you like, of the pathogen. Um, and that way, injecting it into your bloodstream doesn't make you feel unwell. Now, step 2 onwards is where this story is going to quickly become quite familiar to you, I hope. So step 2, the lymphocyte with the correctly shaped antibodies will be activated and divide. So we haven't injected a whole pathogen, but we've injected an inactive form of it or fragments of it, which means there are still antigens present. And so the lymphocyte that has the correctly shaped antibody is still going to be activated, just as if the person had been exposed to the pathogen kind of as normal, like naturally. And then step 3, some of these activated lymphocytes, remember they grow and divide and make lots of identical copies of themselves. Some of them will secrete or release many antibodies which will bind to the inactive pathogen and destroy it. And then others become memory lymphocytes and remain in the bloodstream. And thanks to those memory lymphocytes, if the person was infected with the same pathogen again, they would be immune to that pathogen because the memory lymphocytes would allow them to respond so quickly that they wouldn't feel ill. So if you were spotting the difference between how the specific immune system works and this, it's only step 1 that's changed. Next, a quick look at herd immunity, which is something you'll probably have heard loads about in the news recently related to COVID. You need to know the definition of it, and you may already have an idea of what this means. And the definition that you need to know is that herd immunity is when 95% of the population are immune to a disease. The idea of herd immunity starts to work, I suppose, at a lower percentage than that, but in a dream world, it's when 95% of people are vaccinated or immune from having caught the disease itself, so it's either or. And that does mean that the remaining 5% of people who haven't been vaccinated, perhaps because they're allergic to the vaccine or something and they can't, these people are also less likely to get the disease. But you must be very careful. Spread is not prevented. The disease can still be spread to this 5%. It's just less likely that they'll be infected. Here's a diagram to show herd immunity. Pause the video and have a read. So blue people are not vaccinated and healthy, green people are vaccinated and healthy, and red people are not vaccinated, sick and contagious. So if we have a look at the top row, we have got no one vaccinated and 2 infected contagious people. And as time passes, lots and lots of people become infected too. And then if we look at the second row, some of the population gets vaccinated, so there's 4 of them. We've got 2 people who are ill and contagious, and then as time passes, we have more people who are infected, but it's less than before. So we've got 7 infected people this time, whereas we had 9 last time. So the spread has been reduced just slightly. And then the row on the bottom, most of the population are vaccinated, so there's lots and lots of people who are happily vaccinated now. We've got our 2 people who are infected and contagious, and then as time passes, we've still only got 2 different people who are infected and contagious. So the spread has been vastly reduced, but not prevented. Now we know how vaccinations and herd immunity work, I want to think about advantages and disadvantages of having vaccines. So it's interesting, and again in the news at the moment, we're hearing lots of people saying you must get your vaccine, it will save lives, and you've got some people saying no, don't have a vaccine, it's going to cause you all sorts of health problems. So have a little think to yourself, maybe chat to the person next to you. Can you come up with at least 1, maybe 2 or 3 advantages and disadvantages of vaccinations? Okay, here are the ones that I came up with. I've got 3 pros and then really only 1 con with a couple of kind of examples. So my pros are, the first one's really obvious: less people get the disease. If you're vaccinated, you are immune, and so you're not going to catch the disease. But then, kind of building on that, the next advantage is that with less people getting ill, that means there's less pressure on healthcare providers, so for example the NHS, to have to treat serious illnesses. And then also linked to herd immunity, if we can achieve herd immunity, then even those people who are unable to be vaccinated or choose not to be vaccinated, they are also protected. And then in cons, I've put that there's a low risk that people may react badly to a vaccine. So there is the possibility of an allergic reaction. And then a little statistic for you: 1 in 900,000 people who have the MMR vaccine get a high temperature or have a fit. Um, and then, kind of linked to the MMR vaccine again, you may have heard about this. It was in the news a long time ago. There was a scare created by the media based on one kind of bad piece of research that suggested there was a link between MMR and autism. So I'll show you a bit more information about that on the next slide. So you don't need to take notes on this. It's just a really interesting kind of story. So this MMR vaccine and autism scare all came about because of the Wakefield study, which was conducted in 1998. And the study essentially suggested that there's a link between MMR and autism, or the MMR vaccine and autism. So in the study, there was a slight flaw, which is that there's only 13 participants. That means really there's no way that group of participants represented fairly a whole population at all. So you can't apply the results of this study to a whole population. It really only works for those particular 13 people. Um, and then there's some more evidence against this study. So in Canada, there has been a declining MMR vaccine uptake, so less and less people have been having the MMR vaccine, yet there has been an increase in autism seen. And then similar story in the UK, vaccine uptake remained constant over 6 years, but autism increased. And actually in the US, vaccine uptake remained constant for 12 years, but autism increased. So that's over an even longer period of time. And the reason this became so massive, this story, is because the media took it and just ran with it. They didn't kind of critically analyse this piece of research, which is what scientists have to do. It just takes some time. So the media obviously had a little jump start on it, and they used a lot of really negative language about autism, and they created this drive to find a cure for autism, which really isn't needed. We now understand autism a lot better, and it's not a condition to be treated. It's just a difference in the way that people's brains work, and so this link anyway between the MMR vaccine and autism has been kind of completely disproven. Continuing on from that, examiners sometimes like to put questions about this MMR autism scare into the exam paper. So although it's something you don't have to learn about, it's not on your spec, sometimes they pop it up in questions. So I want you to practice this question, and it's showing you a graph where you can see the percentage of children vaccinated with the MMR vaccine in the kind of bars of the bar chart, and then the number of children who developed autism per 100,000 of the population, which is the line part of the graph. I unhelpfully haven't put the actual question on here, so I will make it appear on the screen now. And it is: the data in the graph support the view that there is no link between MMR vaccination and autism. Explain why. And this is a 4-mark question. So pause the video, give yourself 4 minutes to answer. The things you could have said are that the percentage of children vaccinated decreases to 0 by 1995. Linked to that, while the vaccination rates fell, the number of children developing autism rose and fell. So you can see, if you look at the bars, they just go down consistently. Number of vaccinations is decreasing, but actually the number of children developing autism increases for a bit and then decreases. So, really, there's no correlation between that data. Another point is the number of children developing autism peaked after MMR vaccination had stopped. So, when no children were being vaccinated against MMR, this is when we saw the highest number of children developing autism. And all of those three things together suggest that something other than MMR vaccines were causing autism. So there's not a link between the two. And that's explained why the data is showing there is no link. And that's it. If you have time, give the worksheet a try. Tag me on Teams posts if you have any questions.